Yes, we are looking at implicit differentiation. As you can see here, implicit means that y is embedded in the equation. Y is not the subject of the relation. Y is not a function of x. So if you see this kind of problem, you have to differentiate them implicitly. Now, if you see here, this is y here, y here, y here, y here, y here, y is all over the equation. So we are going to be differentiating it implicitly. Now we are going to be applying the rules of differentiation to it. And one thing you should also remember again that anytime you differentiate y, we are going to be including the y, the x. Very, very important. Anytime we differentiate y, include the y, the x. Now let's see how we do that. Let's pick one of these four. I'll be leaving others for you to practice. So let's take number 3. In number 3, we're having 4y squared x minus 5x squared y 3 plus 4y equals to 0. Now we are going to be taking, anytime we see x and y, we take them as product. Now in this product, we are applying the product rule. In the product rule, we differentiate one, we leave the other one, plus the addition of differentiating the second one, leaving the first one out. That is the product rule. So we are applying the shortcut here. So here, this is y squared times x. Let's differentiate y first. Differentiate y, use the power and times it. 2 times 4 gives us 8y x. So we differentiated this y and we left x alone. But since we are differentiating y, we had our dy dx plus the differentiation of x now, not y. If you differentiate x now, power here is 1. 1 times 4 gives us 4y squared. Minus 1 from it, you get x raised to power 0, which is 1. So we have to differentiate this first one using the product rule, having this. Now, let's go on to the second one. Let's differentiate the first one here is x raised to power 2. So if we differentiate x raised to power 2, the 2 times 5 will give us minus 10x. So we are going to be leaving y raised to power 3. Now, let's now differentiate y now. So the power of y there is 3 times 5 will have 15. Then y raised to power 2, we have differentiated y, and still leave x raised to power 2. Since it is y we differentiated here, we put our dy dx here. Now we are done with the second one too. Now we go on to this third term. If you differentiate plus 4y, the power of y here is 1. 1 times 4 gives us plus 4, y raised to power 0. So that is, since we are differentiating with respect to y, we put our dy dx here. Now equals to 0. We have finished differentiating all of it. Now, when you are done differentiating each of them, you are now going to collect like terms. All the ones that contain the y dx, the y dx, and the y dx, you bring them to one side. You leave them on the right, on the left hand side. Like this one, 8xy dy dx. And another one is this, minus 15y squared s squared dy dx. The another one is this, plus 4 dy dx. Leave them on the left hand side, and others, you take them to the right hand side. If you bring this one first, this one change to plus, we have 10xy3. Then another one is this, does not have the y dx, so bring it there, change it to minus 4y squared. Now we have collected like terms here. So what we need to do next is to bring the like terms outside. We have the y dx. Open your bracket, we are left with 8xy minus 15y squared s squared plus 4, close our bracket, equals 10xy3 minus 4y squared. Now with this, we can easily make the y dx the subject of the relation by dividing by all of this. So if you divide both sides by all of this, we have our dy dx equals 10xy3 minus 4y squared, everything divided by 8xy minus 15y squared s squared plus 4. So this gives us our final answer as our dy dx. That is how to differentiate implicitly. Now we can look at another example and do that. Let's pick our number 2. If we are taking number 2 faster, now we have s squared plus y squared equals to 4. If you differentiate y here, there's no product here. If you differentiate with respect to x here, we have 2x. If you differentiate with respect to y here, we have 2y. Since we are differentiating y, we put our dy dx. Because if you differentiate this one, we get 0. So you leave only this one that is containing the y dx on this side. You now have 2y dy dx equals, take this one to this other side, become minus 2x. You now divide both sides by 2y. You now have your dy dx equals minus 2x divided by 2y. So we can see they have something in common. These two can cancel these two. So we have our dy all over dx equals to minus x all over y as our final answer. So differentiating implicitly is as simple as this. I hope you enjoyed this video. Any question, leave it in the comment section. I'll see you in my next video. Have a wonderful day. Bye bye.